This company is currently in possession of several on-premises relational and NoSQL databases. As the first part of our solution to migrate this data into the cloud, we will first focus on relational databases solution. Relational databases have been a prevalent technology for decades. Relational databases provide a store of related data tables. These tables have a fixed schema, use SQL to manage data, and support ACID guarantees. Now, let's talk data ingestion stage. This is the first part of our data factory. However, more on a data factory in a bit. In the ingestion stage, all of our data sources and any updates are exported periodically into a staging area in Azure Blob Storage. What is Azure Blob Storage? This is Microsoft's object storage solution for the cloud. The blob storage is optimized for storing massive amounts of data and mainly unstructured data. Some of capability highlights include storing files for distributed access, storing data for backup and restore, disaster recovery, and archiving. More importantly, the most important capability is that it's capable of storing data for analysis by on-premises or Azure hosted services. That is our highlight. Users or client applications can access objects in blob storage via HTTPS from anywhere in the world. Objects in blob storage are accessible via the Azure Storage REST API, Azure PowerShell, Azure CLI, or an Azure Storage Client Library. Client libraries are also available for different languages. This provides extensive utility on different tools, different capabilities for different users. We understand that there is different approaches to solving any solution, and that is why we have implemented this service for you. We are focusing on Azure Storage Blob due to its support in low cost, tired storage, high availability, strong consistency, disaster recovery capabilities, and assistance with our NoSQL data. More on that when we touch on the NoSQL solution. The main advantage is that Azure Data Factory supports copying data to and from blob storage by using the account key, a shared access signature, a service principal, or managed identities for Azure resources. So our objective and the first stage of our data factory is to take all of our data, in this case our relational database data, into the blob storage to prepare it as the first step in our data factory. Next up and finally is our data factory. So the data factory is basically an all-encompassing term for a myriad of tools and services at our disposal. We are going to be using the data factory to first take in all of the data that we have turned in from our storage blob, build a pipeline to then transport that data into our next stage, which is Azure Synapse. We'll go into details about that in 1 second. So the data factory basically builds this pipeline, which can be then used to transform data. Well, the reason we are focusing on the data factory is due to its cloud-based ETL and data integration services that allows you to create data-driven workflows for orchestrating data movement and transforming data at scale. Using the factory, you can create and schedule data-driven workflows, which are the pipelines that can ingest data from disparate data stores. You can build complex ETL processes that transform data visually with data flows or by using compute services such as Azure HD Insight, Hadoop, Azure Databricks, and Azure SQL Database. The crown to this is Azure Synapse. Additionally, you can publish your transformed data to data stores such as Azure Synapse Analytics for business intelligence applications. The way this works is by a series of interconnected systems that provide a complete end-to-end platform for data engineers. With Data Factory, you can use the copy activity in the data pipeline to move data from both on-premises and the cloud source data stores to a centralization data store in the cloud for further analysis. Hence, that is one of the goals we are trying to meet. Bring in our data, wrangle it together, transform it, and ultimately bring it into a centralized data store. A very important feature of the Data Factory is its ability to transform and enrich. After data is presented in a centralized data store in the cloud, process or transform the collected data by using ADF mapping data flows. Data flows enable data engineers to build and maintain data transformation graphs that execute on Spark without needing to understand Spark clusters or Spark programming. This service also supports hand-weaved code, so all of our hardcore coders are not left out. ADF supports external activities for executing your transformations on compute services such as Spark Data Lake Analytics and machine learning. After we successfully built our data pipelines, we can take advantage of the link services that the Data Factory provides to then transport all of our fixed data, which has been transformed into one scheme, to bring it all together, organized and neat into Azure Synapse. And the next part in our Data Factory is Azure Synapse Analytics. So last in our Data Factory, we were talking about pipelines. So once again, the pipelines are these tools that transform and transport our data from one end to the other, where Azure Synapse Analytics is our point B, meaning our target. So the Data Factory allows for extensive personalization of the pipelines and its executions, which is a very important part of why we are using the Data Factory. Next up, these pipelines take the data into Azure Synapse Analytics, a service which is basically the manager and the sole storage of all of our data. The Azure Synapse Analytics service basically is our centralized one data store to rule them all. Azure Synapse is an enterprise analytics service that accelerates time insight across data warehouses and big data systems. Azure Synapse brings together the best of SQL technologies used in enterprise data warehousing, Spark technologies, which is in right now, used for big data, pipelines for data integration, and ETL, ELT, and deep integration with Azure services such as Power, Business Intelligence, Cosmos, Database, and Azure Machine Learning. Those three services are going to be our three last steps to take our data into a meaningful vector direction. Part of Azure Synapse Analytics is that it contains the same data integration engine and experiences as Azure Data Factory, allowing you to create rich at scale ETL pipelines without leaving Azure Synapse Analytics. This means that all of the work is done in one centralized hub, taking away different tools or the need to go out and seek out different sources just to have the ease for the user to have it all in one area. Some of the best capabilities of Azure Synapse include the ability to ingest data from 90 plus data stores, code-free ETL with data flow activities. We can orchestrate notebooks, Spark jobs, stored procedures, SQL scripts, and more. Well, now by this point, we've hatched a solution for our relational database to successfully migrate raw data from on-premises data stores to a cloud-based storage, the blob, to then process and transform our data to then deposit it into our centralized data store, which is inside our data factory. Now, NoSQL will follow the same architecture, however, with a different service in between. This middleman is essential because NoSQL is basically based on non-relational data stores, non-normalized, unstructured, or semi-structured data. We will take this by tackling it with Cosmos database services. Now, onto dealing with our NoSQL data. So, in order to work with our several NoSQL data stores, we will migrate this data onto the cloud via Azure Cosmos database service. The Cosmos database acts like a middleman in between the NoSQL data and our data factory. This will act like a storage blob did for our relational data. So this is basically the staging platform for our NoSQL data that we will be using. Azure Cosmos Database is a fully managed NoSQL database for modern app development. Some of its capabilities include single-digit millisecond response times and automatic and instant scalability. This guaranteed speeds at any scale. This is one of the main reasons why we are choosing Cosmos Database to deal with our NoSQL data stores. Why Azure Cosmos though? Do you need another reason? Of course. Azure Cosmos Database takes database administration off your hands with automatic management, updates, and patching. It also handles capacity management with cost-effective serverless and automatic scaling options that respond to application needs to match capacity with demand. So this means that we can activate any workflow or any of our needs at our disposition. This will create predictable cost for our company, which we can deal with in an organized manner. Here are some of the positives of this NoSQL database. It allows for distributed unstructured data, which is distributed in multiple data stores, to be searchable. This means that all this different structured data will be brought in an organized and neat fashion to be able to then be moved onto our centralized data store. Other tools that Azure Cosmos shines through is the different APIs it offers, which include SQL, an API for Mongo database, for Gremlin, an API for Cassandra, and API for SQL tables. Azure Cosmos database will be able to predict any unstructured data that your stores contain, then will neatly access it into one of the four schemas, which are key values, column families, documents, or graphs. Some of the most important uh, uh, capabilities of Azure Cosmos is their optional services. So we already reviewed how Cosmos Database is going to be our middleman in between our NoSQL data and our centralized data store within the data factory. Apart from being our middleman in between our stores, as Cosmos Database will allow for certain amounts of data, which is going to be a little limited, to be stored onto the blob, which allows for more cost-efficient applications. Another highlighting service of Cosmos Database, and the main reason we are picking this service for our NoSQL database, is its ability to link its services seamlessly in between the Cosmos Database and Azure Synapse Analytics, which is our centralized data store. Now, on to our final step. Let's quickly review the progress of our solution implementation. We've successfully migrated on-premises data onto the cloud platform using cost-effective services to maintain high levels of organization and small bills. All of our data, structured and unstructured, has now been transformed and moved into our one and only centralized data store in Azure Synapse within our data factory. Now, with all of our organized data ready to be implemented, we move on to the final services in our architecture. Azure Analysis Services is a fully managed platform as a service that provides enterprise-grade data models in the cloud. Use advanced mashup and modeling features to combine data from multiple data sources, define metrics, and secure your data in a single, trusted tabular semantic data model. The data model provides an easier and faster way for users to perform ad hoc data analysis using tools like Power BI and Excel. This is our ultimate goal of using our transformed data. A highlighting capability of the service is its monitoring and diagnostics. Azure Analysis Services is integrated with Azure Monitor Metrics, providing an extensive number of resource-specific metrics to help you monitor the performance and health of your servers. In Azure Portal, you can create a server within minutes, and with Azure Resource Manager template and PowerShell, you can create servers using declarative templates. With a single template, you can deploy server resources along with other Azure components such as storage accounts and Azure functions. Azure Analysis Services will be the tool your users will use to manage overarching implementation of our clean data. This means that with Azure Analysis Services, we will be able to administer proper rules to our data, protection, and priority. This service is flexible in design, allowing for different tools to be used with it. Your favorite coding platforms, shells such as Visual Studio, and more. The analysis service allows for management of our data from Power BI service platform, granting permission to according users. The Power BI service platform is basically the Power Business Intelligence service that we will be using in our final step within our architecture. Power Business Intelligence is a collection of software services, apps, and connectors that work together to turn your unrelated data sources into coherent, visually immersive, and interactive insights. Your data may be an Excel spreadsheet or a collection of cloud-based and on-premises hybrid data warehouses. Power BI lets you easily connect to your data sources, visualize and discover what's important and share that with anyone or everyone you want. This means that with the use of Power BI service, we will be able to connect into our data factory, into our centralized data store to effectively use that data to produce results and meaningful data-driven insights. Power BI consists of several elements that all work together, starting with these three basics. A Windows desktop application called Power BI Desktop, an online software as a service called the Power BI service, Power BI mobile apps for Windows, iOS, and Android devices. These three elements, Power BI Desktop, the service, and the mobile apps. These are designed to let you create, share, and consume business insights in the way that serves you and your role most effectively. With this service, we will be able to effectively conduct objective driven tasks to then present solutions to our users, being anyone within our company and to all of our customers.